Are you still awake?
Yeah, yeah.
Not the easiest slot for my last talk at Worldline, but I will try not to make you asleep. Yet another talk about generative AI. But I propose a specific perspective, a developer perspective. First question, how many of you have heard about LangChain? Okay. Quarkus. Okay. I have the good attendees. The good news is that I'm not a data scientist. I am not an AI specialist. I'm just a Java guy. And my concern during this talk is how, as Java developer, or Kotlin developer, I don't exclude you guys, can leverage LLMs impressive capabilities in our Java applications. A few words about LLMs. I guess you already know that blah, 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 blah. What is interesting here is the concept of transformer architecture, because it has been designed by Google in 2017, I think, based on what is called attention mechanism, with a well-known paper, Attention is All You Need. And this has been a breakthrough because this principle enables to capture long-range text dependencies. And with previous models, it was very difficult, and this has been the breakthrough. And what is amazing for me is the basic feature is very simple. Predict the next probable token. Wow. And just with that, we can mimic the way we human beings think, create, and communicate. For me, this is really impressive. So there are several kinds of models. Generic models, also called foundation models, which are trained on a huge quantity of data. Specific models, which can be fine-tuned on specific domain. They can be delivered in different sizes. In particular, nano, for instance, for mobile phones. You will have an LLM in your mobile phone soon. What is very interesting for us as Java developer is that they expose a REST API. There is no standard in that matter, even if OpenAI tends to be the de facto standard. And it is still highly innovative, active, competitive. Each week brings a new innovation. This is a traditional Java application, what we have done for years and years, and monolith, microservice, but it's always the same thing. The business logic is implemented. It uses third-party services, external remote services, database, to serve user requests, typically through a REST API. We all know that a new kind of beast is coming, the LLM. And the LLM is yet another third party, but it has a main characteristic. It is creative. And creativity is not a bug, it's a feature. And creativity is not to deal with when you are a Java developer, because it means that you have the guarantee to get the same answer to the same response. Typically for testing, assert true, assert false, it's clearly not enough. You need something like assert maybe, a kind of scoring model to evaluate, yes, this is more or less what I expect from the LLM. So for us, developers, it changed the way we test, and it also changed the way we interact with users. Typically, we can put a chatbot in front of a very complex REST API to facilitate the user. I will explain with a demo after. First question, how do we integrate with LLM from a Java or a Kotlin application? First approach is to use the REST client, because each LLM exposes a REST API, so you can basically use your favorite REST client. You have to know the protocol, the structure of the message, and so on. Again, there is no standard in that matter. You can use a specific SDK like the one provided by OpenAI, so it's a higher level of abstraction, but your application still depends on that specific LLM. You can use a framework like LangChain, and the benefit of this framework is that you have a higher level of abstraction. You can communicate with different LLM, use different vector database technology in a, let's say, uniform way. Low no-code is also possible with tools such as Flowise, and you can also an orchestration tool like Regna. I propose to focus on this one, which is the most interesting for us Java developer. So LangChain. LangChain is it's still true, I guess, the most popular framework regarding generative AI. It has been released just after ChatGPT, early of 2023. But there is a problem for Java dev. It is only available on Python and JavaScript. So basically, LangChains offer a uniform way of using, I would say, plenty of technologies, features related to generative AI. If you want to do it in Java, you have to use, you don't have, but it's recommended to use LangChain for Java. It is the Java version of LangChain, but in fact the two products are totally distinct, and the communities are distinct. It's much more than an adaptation or a copy of the original LangChain. It's a total redesign to better fit the Java ecosystem. I like to see it as a hibernate of LLMs. I guess you all know more or less what is hibernate. It's almost the same thing. If we go to the, I will try to go to the GitHub just to have a look. So this is the GitHub of LangChain 4G. Of course, it's open source. The code is available on GitHub and so on. You have a core part here, which define, I would say, the main API, and you can see that there are plenty of modules, about 60 of them, related to different vector store, different LLM, and so on. So clearly, the comparison with Hibernate is good for me. Woo-hoo. Okay. LangChain 4G is based on Java 8, which is both a strength and a drawback, I would say. It's a strength because Java 8 is unfortunately still widely used in the industry. It's compliant with the old Android version, so it enables to have a large scope of use. Okay, and in particular, we have seen that running LLM on mobile phone will become something very important. But it's a weakness if you want to integrate it in a, I would say, modern framework like Quarkus or Spring Boot, because the Java dependency versions are old. You have to deal with the old native version, blah, 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 blah. That's why Quarkus proposed an extension. So some of you already know Quarkus. What is Quarkus? Basically, it is a modern, yes, we can associate Java and modern, it's possible. It's a modern framework to develop, I would say, a cloud-native microservice application. It's a Java-y new look, let's say. It's clearly an alternative to Spring. I don't want to enter a debate, but today, if you have to develop a new application, for me, you have to choose between Quarkus and or Spring, according to what you prefer. Quarkus has a concept of extension, which enables to integrate external technology in its ecosystem. Quarkus has an important technical characteristic. You can run your bytecode either in JVM mode, traditional JVM mode, or in binary mode, with GraalVM, you can compile your bytecode and run it as a Windows, a Linux, macOS executable. Okay? And that's why it's necessary to have extension to really fit in this strong ecosystem, I would say. It is based on the Java 17, okay, and it enables to use long chain in a very long chain 4G in a very comfortable way in the Java ecosystem. There is an alternative, Spring AI. How many of you have used Spring AI or heard about it? Okay. So Spring AI, from what I have understood, is typically comparable to Longchain 4G. It is inspired from Longchain and Llama Index, but it doesn't reuse them. Okay? They have redeveloped from scratch. If we compare the code, what is the best option? To reuse an existing framework like Longchain 4G, or to reinvent from scratch? This is debatable. If we have a look at this figure, we can see that Longchain 4G and Spring AI are very comparable in terms of 100,000 lines of code. It's normal. They do the same with a different approach, but they do the same. Quarkus on 4G, as you can see, there is a lot of code in Quarkus of Longchain 4G, about half the size of Longchain 4G, because it's a really deep integration of the original Longchain 4G. For instance, all interactions with LLMs are done with the Quarkus REST client. So it's really a deep and complex technical integration. Okay? So both approach are Spring AI to rewrite from scratch, or Quarkus to reuse Longchain 4G. Both approach are interesting and provide, I guess, the same result. This is a timeline that illustrates the very fast pace of change, and it accelerates on the right. It's not finished. The transformer architecture, just after the release of GPT-1, ChatGPT, we have all discovered the power of LLMs with ChatGPT end of 22, and then just after, all the framework I've discussed. MicroProfile, I don't know if you've heard about MicroProfile. It's a set of specification, of Java specification to implement a cloud-native microservice application, and we have just started a new specification. I'm part of the working group, and if we consider that Longchain 4G is a hibernate of LLM, let's say that the ambition of MicroProfile AI is to become the JPA of LLM, a common level of abstraction. It is just starting, and the question we have is it reasonable regarding the activity, the innovation rate? Is it reasonable to try to define a standard right now in that matter? Not that easy. Let's deep dive a little. So to experiment, I have developed a car booking application, very easy car booking application using Quarkus, Longchain 4G. Different GPT version we have available at Worldline 3.5, 4.0, with a focus on RAG. You all have heard about RAG, Retrieval Augmented Generation. Basically, RAG is about enabling the LLM to play with your own data, as we will see. Function calling is about allowing the LLM to play with your business logic, to call your function, your Java code, for instance. It's available on GitHub. I've made it as simple as possible. Where is the discussion? Not, ouais, okay. So let's present the application. It is as simple as possible. No database involved. You can just clone it, configure the endpoint and your key, and it should work. The purpose of this small application is to answer to this kind of question. unfortunately, I cannot make the demo here, but typically, hello, how can you help me? What is your list of cars? What is your cancellation policy? What is your fleet size? Can you cancel my booking? And it also enables to detect whether a user is a frauder or not. Very easy, no database involved. And what is interesting in that application, there are two what Quarkus called AI services. What is an AI service? It's an interaction with the LLM. I'm sorry, I'm going to show some piece of code. Okay. How do we define an AI service? So an AI service is just an interaction with the LLM. Very easy, you just define an interface. Here I have a chat AI service. The method, the signature of the method is very easy, chat. I just received the user message, I send it directly to the LLM, and the response code is just the response of the LLM. Could not be simpler. Okay, these are fallback, timeout, retry, fallback. These are fault tolerance annotation. Nothing to do with generative AI, but it illustrates the integration with the Quarkus ecosystem. So I define a chat method, and we have an interesting annotation here, system message, where we define the context. We say to the LLM, oh, you're a customer support agent of a rental car company called name miles of miles, blah, 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 blah. We define exactly what we expect from the LLM. Don't forget that the LLM is very generic. He knows almost everything, but you have to specialize him for a specific use. And we have another register AI service annotation here, and with this annotation, Quarkus is able to detect the interface and to generate the code automatically for you. You do not have to do anything, just code an interface. Yes?
Is there some code that loads that power?
Yeah, we'll see that after. Good question. Yes, because during my test, I had some problem about the cancellation policy, and I have decided to put it in the system message. Any question related to the way we define? Okay, so another more complex AI service, fraud detection. This time, I do not want just to send a message a raw message to the LLM and response with the answer. I want something more structured. I have a method. I expect the name and the surname of the customer, and my answer is fraud response, something that is structured. And the main difference with the previous example is that I have specified a user message. You have the system message. You are a car booking fraud detection AI for my last mile. And in the user message, I define the role to detect the fraud. Okay? I provide some concrete examples, and I ask the LLM to answer with a valid JSON document, including the name, the surname, is a fraud detected or not, and in case of fraud, what are the reservation IDs that cause the fraud. And the magic of the framework is that fraud record it's a fraud response. It's a Java record containing the name, surname of the user, Boolean fraud detected, and a list of booking. And automatically, the framework transforms the JSON response into this Java record. So you have seen the difference between the chat service, which is not structured at all. This one is much more structured, and this parameter name and surname, name and surname, this parameter, you can see that there are variables here to replace concretely by the name and surname provided. Just a small overview of the configuration. The configuration is also simple. Basically, you define the endpoint of your Azure OpenAI. In that case, it is Azure OpenAI endpoint, your API key. You can log the response and the request. Here, I have asked to log the request and the response in dev mode, and only the response in test mode. There are two interesting parameters here. Do you have an idea? Do you know what is the purpose of the temperature and the top priority? It is to decrease the creativity of the LLM. You cannot remove the creativity. You can decrease it or increase it depending on your use case. And there are recommendations from OpenAI. Sorry, I wasn't at the right place. Yes. Attends, excuse-moi. Toc. OK. Sorry. OK. You can influence the creativity and the determinism depending on the use case you want to process. Typically, when you want to implement a chat, you are in the middle. You want to have some creativity. When you are in mode exploratory, you want more creativity. For code generation, not so much creativity. I would say it's enough creativity like that. And you see, depending on your use case, you can influence the creativity, but again, you cannot remove it. These are the basic principles. So, basic Java interfaces with specific annotation, configuration. Let's switch on RAG, Retrieval Augmented Generation. Everybody speaks about RAG today. RAG, everywhere. The LLM have been trained on a huge quantity of data, but they don't know everything. In particular, they don't know the details of your organization, of your team, of a specific domain. So the objective of the LLM is to augment of the RAG is to augment the LLM with specific knowledge, which can come from PDF, text file, CSV, whatever. How does it work? First off, the input text is turned into a vectorial representation. It is very important to have this representation to determine the proximity and the probability of tokens. This representation is stored in a vector database. It can be in memory, which is enough for a demo. It can be in Postgre. There is an extension, PG Vector, which allows to store vector, Redis, Chroma, and so on. So this process of turning text into vector database is called the embedding. And then after, upon each request, the request is completed with relevant selected data. With Quarkus, there are two ways to run the embedding. Either you do it remotely. For instance, you call OpenAI, please embed this document and this one, or you do it locally with a small model. This is the option I have used for the prototype, for my demo. Some code again. Alors, In my demo application, I have a directory, docs for RAG, it speaks for itself, with different text information. I should have put PDF files, no matter. There is a file describing, providing general information about on the company, how many employees, geography, number of cars, and so on. There is a file containing the list of cars available, a file containing the terms of use, including the famous cancellation policy, and an apple pie recipe, nothing to do with car booking, but I have put here to check the selectivity, the precision of the selectivity of the embedding process. Then these files are ingested, they are embedded with a specific class ingester, so nothing complex. You load your documents and you embed them using an embedding model in an embedding store. Here my embedding store is just an in-memory embedding store. This is very fast, by the way, and in my project I do it at application startup. It lasts about 200 milliseconds, no, not so much, and then after automatically a doc RAG augmenter is called. And the role of this doc RAG augmenter is, regarding the query provided by the user, to retrieve the relevant content and to add them to the query. Under the hood, let's see a typical request that is sent to the LLM. So this is an OpenAI request. We have our system message, our user message. In that case, my user message is, my name is James Bond, what are my reservations? And you can see that the system has automatically added answer using the following information, and then you find all the relevant text related to my question that are sent to the LLM. Because one important point, the LLM is stateless. Okay, so each time you have to repeat, you have to precise the context of your request. So this is automatically done by the framework. So at the beginning I was very disappointed because in my mind I imagined some kind of binary. Complex binary representation of vector sent to the LLM, but it's just text. In fact, the vector representation just serves the purpose of selecting part of text that seems relevant according to the question. Not very elegant, but efficient. With the new version of with the new version of Quarkus, you do not have to code anything. You just have to configure the directory containing the document you want to RAG, and the retriever and the ingester class I have shown you, you don't need them. But there is a but. I will come back to that in my conclusion. Easy RAG means naive RAG. And in production, naive RAG is not the good way to go. So this is very interesting for demo, to understand the principle and so on, but to have production-ready RAG is much more complex. I will come on that later. Function calling. Function calling is another interesting aspect when you are a developer. You instruct the LLM to call your functions. Wow, dangerous. It can. What is a function? A function is just a Java method annotated with tool and a comment which explains to the LLM what the tool is supposed to do. Function descriptors are sent in the request. The LLM decides whether it's relevant to call a function. If yes, a description of the function call is provided in the response, and the framework automatically calls the tool method. 10 minutes? You're serious? It's my last talk. I need more.
You can be.
Okay. In my example, let's see concretely how it works. All the business logic, it's a big word, business logic, but is centralized in a booking service class. You have get booking details. You see, it is exposed as a tool. I provide a message, get booking details of for a customer, and so on. I have another tool, get bookings for customer, and another method, cancel booking. Very important, the way you formulate what is supposed to do the tool. And how does it work? In a few words, request for JSON. How does it work under the hood? I like to see how it works under the hood. This is the request. We have seen it previously, and you can see that there is an array containing the description of all functions that have been detected into the code. It's sent to the LLM, okay? The LLM runs its business logic, and at one time it says, oh, you need to call this method. And in the answer, we have typically this kind of answer. First, finish reason function call. That means, please, you must call a function. And then you have the description of the function, including the parameter. This is for the main principle. So what does it mean in terms of perspective? It means we can use the LLM as a kind of workflow engine. The LLM is entrusted with the decision to call business logic, which can be dangerous. Don't forget it's creative. If you have a payment function or something like that. So it's both powerful and dangerous, but it's really, really interesting if properly used. An example. I am James Bond, can you cancel my booking? Blah, blah. The application sends a first request. Okay, the LLM answers, please call get booking details. I need the details of this booking to determine if it's cancelable or not. It is executed. A second request is sent to the LLM. The LLM determines, yes, this booking is cancelable. Please call the cancel booking method. Cancel booking is executed. The result is provided in a third request, and we have the final answer, finish reason equals stop, and then we can answer the final user. So you can see that for one request in front of the user, we can have plenty of requests in the background. In terms of performance, until a recent date, I had the choice between latency and accuracy. Basically, with GPT 3.5, the latency was good, but the accuracy was not good. Clearly, to enable function calling, GPT 3.5 is not accurate, reliable enough. In contrast, GPT 4 is accurate, reliable, but very slow. Really, very slow. Recently, last week, I have used GPT 4o, and hurrah, I have the benefit in terms of latency of GPT 3.5 and the accuracy of GPT 4. So you can see that things change very, very, very quickly. Listen, learn. What can we say? So clearly, using LLM is technically very easy. We have seen the programming model, nothing complex. Dealing with LLM creativity is counterintuitive for Java developer. Testing is not just true or false. We have impressive advance in terms of performance, precision, and reliability. A new model is coming every week with its own performance. Yes. In terms of debugging, monitoring, and so on, some improvements are expected in the tooling. It's still very, very basic. Regarding RAG, don't be fooled by easy RAG. In production, you need to pre-process your document, to add metadata, to define your splitting and chunking strategies regarding your embedding model, to check under versus overmatching upon each retrieval, and to manage internationalization. It's also an important aspect. Regarding function calling, keep in mind that it's not supported by all LLMs. To be used with care for security reasons, GPT 3.5 not accurate have. LLM creativity need to be reduced. It can be verbose. Parallel function calling is possible. I have not tested it. And conclusion, I'm on time. We are clearly just at the beginning, so everything is moving fast. Hold on and fasten your seatbelt, because it's already very interesting, but it's really, really promising. That's it.